Good evening, everyone. My name is Ingram, and today I'll be performing lab 4, which is our titration lab. The purpose of this lab is to analyze the amount of acetic acid in store-bought vinegar. We will use titration method to gain the amount of acetic acid within the store-bought vinegar. Okay, the first thing we will do is make our potassium hydroxide solution, which requires 1.40 grams of solid potassium hydroxide, which I have right here, already measured out. And next thing we need is 250 milliliters of distilled water. All right, the next thing we will do is place the potassium hydroxide within the water and stir it up until the solid is fully dissolved. I'll be using this butter knife, which was washed with acetone, to stir. Our potassium hydroxide is mixed very well. As you can see, we have no solids left in the liquid. The next thing we will do is prepare our vinegar acetic acid, which is our analyte. First thing we'll do is add 5 milliliters of store-bought vinegar into a clean 250 meter flask. The top of the flask was too small in order for me to put the pH meter in, so we will be using a beaker instead. Give me one moment. Let me get my measurement. Okay. Each one of these pipettes, once filled, equals 1 milliliter. So we will need 5 of these in order to have 5 milliliters of store-bought vinegar. 1, 2, 3, 4, 5, and just a tad bit extra. So you could say between 5.1 and 5.3 milliliters of store-bought vinegar was added. Place that to the side. And now we will add 50 milliliters of water. This has measurements on the side. Has measurements on the side. I also do have. I have a beaker, but it's water flash. That is exactly 50 milliliters. Look on the side. Yes, right at 50 milliliters. Pour this into the vinegar. And I also have my phenolphthalein. Add 2 to 4 drops. 1, 2, 3, 4, 5. Just to be on the safe side. Now we're gonna give that a little whisk. Next, you want to prepare a burette, which I have right here. It's a 50 milliliter burette. 50 milliliter burette. And I have already washed it and rinsed it with distilled water. I actually have distilled water in here right now to keep it clean. I'm currently going to release this water. Okay, while the water is being released out of the burette, I'll let it calibrate my pH meter. So pop the cap. Remember, vinegar, KOH solution, also known as potassium hydrate solution. Okay, so in this cup, to calibrate my pH meter, I have pH powder mixed with water. This is approximately a pH of 6.86. Okay, my pH meter is reading at 6.8 to 6.9, which is perfect. Which means it is dead on. Let my pH meter sit in here. Alrighty. Now that that has been drained of the distilled water, we will now add our potassium hydroxide solution. This is just a reminder that this is a 50 milliliter burette. We want to go a little bit above the 50 milliliters, so that way we can let out some and release some of the air bubbles. So we can have a pretty accurate measurement. And make sure you close your barrette before you pour the KHO solution in. Okay, that's enough. While we do that, a little fit check, long pants, closed toe shoes, and goggles. Alrighty. Next, we'll begin our titration in increments between 0.25 milliliters and 1 milliliter, and swirl the flask between. We'll record the value. But first, I'm going to measure the pH of my vinegar solution and my KOH solution. But before I do that, let's get this right at 0 milliliters. Okay. I'll be ready now at 0 milliliters as it's starting, as its initial amount. So let's get our initial amount of 150 milliliters. Milliliters of vinegar solution. We have 50 milliliters of KOH solution. Okay. So let's label this our first run. All right. Alright, first run, and it is starting at 10:32 p.m. Okay. Okay. KHO solution, and now we will place our vinegar solution under our burette, and we'll do this in increments of just small increments. Specifically, I would say one to 2 milliliters at a time, just to get an idea. This is basically gonna be like our practice run, and then we're gonna run 2 more runs to ensure our data is correct. First, let's measure out our KHO value, pH value. Okay. Our KOH, excuse me, pH value is 12. Our vinegar solution value is at 3.5. All right. Next thing we'll do is place our pH device in here. It is waterproof, so the KHO solution will not affect it as much, will not destroy the pH device. And we just want to record how many milliliters and the pH value as it changes. So, first run, right now we're at 0.0 milliliters, and the pH value is 2.2, 2.5 milliliters pH. Okay. That's 2 milliliters. After 2 milliliters, the pH is at 2.8. And then after 4 milliliters, is at 2.9. Okay. At 6 milliliters, it's at 3. So right now we're doing a constant drop of 2. I'm gonna switch it up to approximately 5 just to make this our speed run. So right now we're at 6. Okay. went to 11 milliliters. pH is now 3.5, and also hints of pink. Let's go 5 more. Okay. After 16 milliliters, we're at 3.7 and still hints of pink. 5 more. Alright, so at 21 milliliters, pH value is 4, and the pink is lasting longer. Let's go 5 more. At 26 milliliters, we're sitting at 4.5. Okay, welcome back, guys. So as of right now, we have entered 26 milliliters of potassium hydroxide solution into the vinegar solution. The pink is lasting around 3 to 4 seconds. And right now the pH is at approximately 4.5. Right now we are constantly adding 5 milliliter increments. Okay, 31 milliliters, we're at 5, and then pink is lasting 5 to 7 seconds. Okay, let's go 5 more. It's 6, so it's 38 actually milliliters. It's at 6. Let's add 6 more. Perfect. So we have our over titrated solution, which is very pink, which is exactly what we wanted. And the pH measured at 11. So if you guys can see, 11 over titrated. So at approximately 44 milliliters, our pH is at 11.3, and the pink is dark and staying. Oh. Now we're gonna run one more run, but the closer we get to our estimated amount of KOH, we're gonna decrease the increments to try to get a more specific amount of KOH needed to balance out the vinegar. The point that we have reached is also known as our endpoint. This is our endpoint. This is the results that we want. Now I'm going to pour this out, rinse it down the drain with the water, and we're gonna add the same amount of vinegar and distilled water that we added the first time. And we're gonna refill. I'll be right up with 50 more milliliters of KOH solution. And it's properly dry. We run out our measurements, so let's make sure we get the specific amount of measurements that we used the first time for the vinegar solution. So 5 milliliters of vinegar. So that'd be 5 full pipettes. 1, 2, 3, 4, and 5. Okay. Now we'll use our flask. Graduated cylinder, excuse me, not flask. Add 50 milliliters of distilled water. All right, right at 50 milliliters. Just pour that in there. Let's give that a good whirl. All right. Make sure our burette is closed. Now let's fill it up back to 50. Excuse me. All right. Now, we're just gonna repeat our same process. Let's get our pH meter back in the solution. All right, the initial pH value of the vinegar solution for the second run pH excuse me, is 2.5. We have 50 milliliters of KOH solution, and KOH pH is, get this wiped off. Is it once again 12.2. Our KHO solution is at 12.2. Now place the pH meter back in our vinegar solution. And now, now we can actually move a little bit faster through this one because we know the exact estimate of how much KHO solution it took to reach the ending point with the vinegar solution. We know it stopped around the 44 milliliter point. So right as I get to around 40, around 35 actually, I'm gonna slow it down just so I can get that precise measurement. As of right now, I'm gonna go in increments of 5 all the way until I get to 35. Okay, so 0.0 milliliters, and pH is at 2.5. Okay, let's add 5. Oh, made a mistake. Phenolphthalein, add 2 or 3 drops. It's okay to add it now, it's not gonna mess up anything. 1, 2, 3, 4. Okay. Get at a good whirl. Okay. After 5 milliliters, we have pH of 3.1. After 10 milliliters, we have a pH of 3.3. After 15 milliliters, we have a pH of 3.7. After 20 milliliters, we have a pH of 4. Okay. After 25 milliliters, we have a pH of 4.3. After 30 milliliters, we have a pH of 4.9. Now, like I said, we were gonna stop at 35 and start doing small increments until we get close to 44, which was the last estimated amount of Potassium hydroxide solution used to help the acetic acid reach its equivalence point. So this will be the last 5 milliliter drop I will do. Okay, so right now, right at 35, right at 35, we have reached our equivalence point. With our pH being 10.6. And just to over titrate, okay. So yes, that is the end of the experiment. But before I end, I would just like to give you a glimpse of my notebook. So right here, we have the first page of the pre-lab, including the purpose, the references, and also the SDS property and safety charts. The next page we have consists of my pre-lab questions. On this page is a continuation of my pre-lab questions and also the beginning of my research plan and experimental T-chart. On this page is a continuation of the research plan and also the experimental T-chart, including data picked up from the first run. And on my last and final page is the ending of my research and experimental T-chart with the data from the second run. Thank you.